Hello friends, this video is on enzyme, and before I really start with my video, I would like to tell you that this is the website where you can find some more videos, that is easyscience.weebly.com, and this is my link for the YouTube videos. You can click on this link, you will straight go to my channel and you can see some other videos as well on biochemistry, and you can subscribe my channel if you like my videos. So let's go to the details of this enzyme kinetics, what is enzyme, and everything. I'll try to to discuss in this video. So enzyme. Now what does this enzyme do? You know that enzyme is basically made up of protein. Only one exception is that ribosome is the only enzyme that is made up of RNA. There is no protein, so this is the only exception, but otherwise most of these enzymes are made up of protein, and sometimes there are some cofactors are associated with this protein group. So these cofactors are responsible for the function of that particular enzyme. Suppose the enzyme is dehydrogenase, so the cofactor will be NAD plus or FAD, so that the hydrogen that this enzyme has taken out from the substrate will be delivered to this NAD plus or of FAD, and it will oxidize those substrate and produce a new product, whereas this NAD plus will turn into reduced NADH plus H plus, or this FAD will turn into FADH2, and both of these will go to the electron transport chain in mitochondria to produce ATP. So here this NAD plus FAT, these are working as the cofactors. Sometimes this vitamin B1 also work as a cofactor. I'll be discussing all these details about these vitamins and everything, these cofactors, in my other videos, but here in this case I will be very much concentrated towards the other towards basically the enzyme kinetics. So if I am drawing a graph in which, if this is the energy level, sorry, this is not a good photograph, so let me draw it here. Suppose if this is the activation energy, which you have to pass before before the production of any product, this is the activation energy, and this is the level. Suppose this is E1 and this is E2. What happens that without any kind of enzyme, this activation energy level is high, very high, but with the help of this enzyme, this activation energy level goes down to this much, and now the activation energy level is this much, so the reaction becomes easy and much more faster. But the enzyme doesn't undergo any kind of chemical changes apart from its cofactors. So the enzyme, nothing but it helps in the in the reaction by decreasing the activation energy, so that the substrate can easily turn into the product, and it doesn't changes chemically at all even after the reaction. So now the next one is the ES complex formation. What happens that if you have a substrate, and if I give enzyme, it will straight away form, it is a backward and forward reaction, bidirectional reaction. It will form enzyme substrate complex, and then it will straight away produce the product, and the unchanged enzyme will be free, which will again go for the next round of reaction. This is the forward reaction, and this is the reaction rate, and this is K2. So this enzyme substrate complex, this is very fast. This production, the enzyme substrate complex production is very fast, whereas this this product formation is very less. So this K1, this reaction kinetics constant, this K1 is pretty high than this K2. This is the rate limiting step. This is the rate limiting step, and this is the slowest step and the main deciding step of the reaction. Now, how this enzyme substrate comes in contact and how all these things happens. The enzyme is very much specific for a substrate. That means the enzyme, suppose there is E1 enzyme and S1 substrate, there is E2 enzyme, and S2 substrate, there is E3 enzyme and S3 substrate. It is for sure that E1 will only react with S1, E2 will only react with S2, E3 will only react with S3. There is no chance that this E3 will react with S2 or this E1 will react with S2. There is no chance like that. So for each enzyme, the substrate is very much specific. And how the enzyme and the substrate approaches to each other and how they form a complex. So if we have to get an idea of this, there are two hypotheses about this enzyme substrate complex formation. One is a lock and key system, lock and key model, in which it states that suppose if this is my enzyme, and if this is my substrate and this is my substrate, this enzyme that perfectly fits with the active site of the this substrate, which perfectly fits at the active site of the enzyme, will come immediately and will form the ES complex. This will never come into this this functional core, this reaction zone of the enzyme, as because the structure is not perfect for the reaction core of the enzyme. So this according to this model, that the substrate structure and the enzyme activity core is always structurally complement to each other. Complementary, they always show the complementarity. This is the lock and key model. In case of the induced fit model, which is a second proposed model, induced fit model, in this case it states that enzyme is in some kind of a form and substrate is there. As the enzyme and substrate approaches each other, then the enzyme perfectly shows its original functional zone, that is the reactivity core, where the substrate will bind and will form the ES complex. This is a substrate, now it has bonded, it is now within the reactivity core of this enzyme, and it will form the enzyme substrate complex. So initially they were not in a kind of a formation, or its structural complementarity was not there. So these two structures are very much dissimilar, but as the substrate approaches the enzyme, it will form a suitable structure, not a suitable structure, it will open its functional area, and so the suitable substrate will will be into that space and will form the ES complex and will proceed this reaction to this side. So I guess this portion was clear to you. Now the next portion that I want to talk about is this, that the how this enzyme functions, like what is the activity unit of the enzyme. Enzyme activity unit, enzyme activity measurement, you can say, that is, there are two process, like one is you denote as U. This is when the enzyme, when 1 mole of enzyme can sorry